we have side A as 15, B is 28, and side C is 17. The first thing for you to notice is that there are 3 sides given, right? So 3 given sides means we have a side situation. That is case number 4 of solvable triangles. We use law of cosines to solve this. So once you have that pinpointed, hey, I know it's case 4, it's a side given, I can find all that unknown information using the law of cosines. Definitely sketch a triangle, right? You want to have a sketch to start with. So I'm gonna just real quickly do a sketch of this triangle. Again, there's nothing special about these angles that I just drew up. It looks like this is the longest. I'm going to call that 28, which makes that side B. Of course, that's across from vertex B. And then I'll put A over here and then C over here. That means side A is 15 and side C is 17. Right? So now I've got a picture that goes along with the given information. Law of cosines tells us that if we know either 2 sides and the angle between them, or know all 3 sides, we should be able to have enough information to only have one unknown, and we can solve for that. I'm going to go, I'll look for angle A first, because I always go smallest to largest. That's a rule that works all the way through for solving any triangle, whether using law of sines or cosines. Find the smallest first and you're going to be okay. So again, I'm looking for the smallest angle. Obviously, it's across from the smallest side. And that means I would have side A squared equals B squared plus C squared, right? Just like a Pythagorean theorem. And then there's always this adjustment to the Pythagorean theorem so that it works for any triangle. I know A. Here's side A, 15. So I'm going to put 15 squared equals, well, let's see, where's B? B, side B, there it is. So we'll say 28. That's 28 squared, right? Plus, all right, we need side C. Side C, right there. So we've got 17 squared, subtract 2 times, let's see, what are those 2 values? It's the same. See these 2 sides we have? It's those same exact sides. So it's 28 and 17. And that's times the cosine of angle A. And that's the one we don't know, right? I'm going to put that right here. Times the cosine of angle A. Now, if you notice all of this stuff, we have everything filled out except for angle A. And we should be able to just use our calculator to finish this thing off. So 15 squared, of course, is 225. Let's see, 28 squared. And I encourage you to go ahead and do this while I'm working through it, or before, pause if you need to. 17 squared is 289, right? 2 times 28. Ugh, this is not fun, right? So we kind of trust our calculator and our ability to estimate. I get 952 times the cosine of angle A, right? Cosine of angle A. I'm going to put these 2 together, and again, you can just feel free to go ahead and skip past some of this. This is mundane tasks going on here, combining integers and things like that. I do want to point out, right here is where almost every mistake in these triangles happens. So many people put these 2 numbers together. Or up here, they put those 2 together, 289 and 952. Order of operations says you can't subtract before you multiply. Remember, this is the product of 952 and cosine of A. So truth is, to finish solving this thing, we actually have to move that 1073 over, right? And this is really algebra 1. So 225 minus 1073. I'm showing negative 848. And that's equal to negative 952 cosine of A, right? And then, of course, our algebra skills tell us if I've got a product and I want just one of those factors, I divide by the other factor, right, to isolate. And so, of course, I notice they're both even. I don't really care about the reducing at this point because we're going to be typing it into our calculator anyway. So the only step left here, I've got cosine of some angle equals 848 over 952. I don't think that's a special angle. And what we should all recognize is that to undo a function, we take the inverse of both sides, right? So we're taking the inverse of that side, the inverse cosine of the left side. And what we end up with is that A is equal to the inverse cosine of 848 over 952. When you type that into your calculator, make sure that you're in degree mode, right? Go to mode, make sure it's in degree, and then we're simply going to type in inverse cosine. I hit second, and then cosine. See it right there? Second cosine. That gives us the inverse cosine. I always like to use my alpha y equals. That gives me the fraction bar. And that's 848 over 952. And I get 27.03. And we'll just round to the nearest tenth. So I'm going to say that A is approximately equal to 27.0 degrees. Okay. Once I have that, I can fill it in my triangle, right? 27 degrees. And then everything else on here, just use the law of sines to get the other missing angle, right? So remember, go smallest to largest. So I would not find angle B next because angle C is definitely smaller. Always work from the smaller up. Once I get angle C, just use the triangle sum theorem, right? You know those three angles add up to 180. Hope this helps.